Okay, good evening. Welcome to
MonsterMath9.
MonsterMath9. So we're doing our video tonight just because I'm gonna be traveling tomorrow. But this is a problem that you saw in your sort of school's math team practice, and this is a really neat problem. You have a 3, 4, 5 right triangle, rotated 90 degrees about its midpoint of the hypotenuse, like that, rotated counterclockwise, right? About the midpoint of the hypotenuse. And you're supposed to find the area of this quadrilateral in the middle. And you had a great solution to this. So we won't go through the calculation, but I want you to explain the solution, and then we can leave the calculation to anyone who actually wants to go ahead and do it.
Okay. So what I did first is I found the area of this right here.
Okay, and what's that?
This is a similar to right triangle because we rotated it 90 degrees.
Okay.
It's also a 3, 4, 5 right triangle because we have this same angle here.
All right, good. Very good observation.
So this is it's not a 3, 4, 5 right triangle, but it's similar to a 3, 4, 5 right triangle.
Okay, so right away you noticed that you had something that was similar to a 3, 4, 5 right triangle there. Okay, good.
So once I figured that out, I needed to figure out what this part is so that I could subtract it away.
Well, there was one more step. Once you saw that it was similar to a 3, 4, 5 triangle, you needed to know more about it.
I needed to find out what side length there was.
Yeah, that was the tricky part.
It said that it had chopped. This is the midpoint of the hypotenuse. So we could figure out what this side was, so that we could then figure out what the rest of the sides were.
Okay, and how long was that side?
It was 2.5.
2.5, so half the length of the original hypotenuse, which is fine. Okay, so now once you know that that's a 3, 4, 5 triangle, you know the longest side leg, is 5 halves, then you can figure out the area of that triangle, but that's not what you're looking for. You're looking for the area of this quadrilateral in the middle. Okay, so what did you do next?
So then I decided that I wanted to subtract this away from this so that I could find out what the small piece was. And I was able to do that by recognizing that we have a congruent 3, 4, 5 triangle here.
Okay, awesome.
So once again, this is 2.5 to here. So then that allowed us to figure out what this side, the hypotenuse of our small, this is also a 3, 4, 5 right triangle.
Okay.
It's the small 3, 4, 5 right triangle. Then we could find the area from there.
Alright.
And then we subtracted that away from the area of this.
Okay.
Which left us with what we were looking for.
Alright, and how did you find, maybe you said it, maybe I just wasn't paying attention, but what did you do to find one of the legs of this triangle?
Well, we just set up the ratio. So I just said that I figured out this was 5 times something.
No, right from the beginning, like the very first step of finding out how long whatever this was, I think. How did you figure that out?
I figured that out by figuring out how long this part was, and then subtracting it away from this distance.
I see, which was, and how long was that distance?
That was the 2.5.
That was the 2.5, okay. And then in that point you had the hypotenuse and you could find out all the other sides. Cool. Yeah, that looked initially like it was going to be a very, very complicated problem. But it was just recognizing a little bit of similar triangles. Cool, that was a really good job. Good job.